Okay, the battery is 10,000 milliampere godziny, 10 amperes. The voltage 19.6. The beeper is set to 3.1 on a cell, and now the power is just under 300, 290, 295. The motors, 4 motors, use around 15 amperes at this moment on this particular battery. Photos later on. Okay, to be honest, I had a problem with vibration, and I stripped the pixhawk. I put some different rubber in there, and I completely changed the damper. Now, as you can see, the barometer is holding the copter right in the position. So this is actually the middle. So let's go down a bit. This is going down, it's just under. The level is, actually it's also just under, so I would say that the motors need around 45% of power or something like that. Actually, I can take the camera. Maybe I'll be able to record it. And this is how the pixhawk is mounted now. I think that's 3.8 per cell at this moment. And okay, let it be like that. Here I put one of the parameters to change, and while I'm going down here, it swings a bit, but then somewhere in the middle, so this is stabilizing P on pitch and roll. It's behaving pretty well. Okay, let's go up a little bit. Okay, this is more or less 10 minutes. Let's take a look at the meter. I have around 15 amperes now, a bit more, 15.1, 15.2. The power is still under 300, but now it is more around 290. The voltage, it's exactly 19. By the way, I can't raise the legs because you can see the wires hanging there. I just turned them off because of this switch. I was using this for the legs. I can see on the camera that the video is 16 minutes now, so probably the flight is 15 minutes. The voltage is 18.7, amperes used is 15.3, and the power is still just under 300 watts. Regarding the problem I had with the pixhawk, actually these motors are designed also for 20-inch props. They are really large and heavy. But when I put them on and tried to fly, I had really bad barometer error. The copter could fly up very quickly or just down. I thought it was the prop wash that came from 20-inch propellers that were pretty close to the center plate, but it wasn't. Actually, I think now that the problem was a bit deeper. First of all, I'm using a pixhawk, and it has a really bad foam covering the barometer. Another thing is that the pixhawk I mounted on the plate using not very soft foams. So what I actually did, I stripped everything. I mean, took my controller part into parts, put a completely different rubber type with holes so the air can go to the barometer in a place of that foam that was just very bad. One more thing, direct sunlight may also change how the barometer works, so I tried to cover as many parts as possible, and that foam was also just completely black, even though the air could go through it. And the last thing, I used a very special rubber type, 1 centimeter thick. A similar rubber type I got with an original pixhawk. Actually, this is an original pixhawk, but when I changed the design how to mount the pixhawk, I just destroyed it, so I couldn't use it. But I remember what the rubber was, and I used to get a similar type of rubber, and I actually used that. So, direct sunlight, completely different rubber covering the barometer, and completely different dampers or anti-vibration system, just made it stay at the same height. Also, I tried the 20-inch propellers. Well, pixhawk needs some adjustment, but it flew. No problems with going up, down, whatsoever. So I should be able to make a test how it flies soon, and maybe I'll take a test of how long it would fly on 20-inch props, with 20-inch props. Okay, the camera has been recording now for 23 minutes, so the flight time is around 22 minutes or something. Take a look. Now let's see the meter. So the voltage is 18.3, amperes used 15.5, and the power actually still the same. The power used is 281, 290, it depends. If I go up a little bit more, but it's still under 300 watts. One more thing. The camera switches off after 30 minutes. It's just hard to control it because it can switch off after 31 minutes or 29 minutes. It's been nearly 26 minutes since I switched it on. I have to switch it off and switch it on manually, then join the movies. Take a look. How the clock is changed, and take a look where the multirotor is. I have to switch it off and switch it on. So there will be 2 seconds, maybe 3 seconds off. Okay, and now I'm back. The beeper is set to 3.1 volts. It measures each cell separately. 3.1 is a bit close to 3 volts, so just as soon as the first beep rings or beeps, I'll just land to protect the battery. The camera turned off. Sorry, but I didn't really change anything, and the copter is still flying. It got warmed up. That's the beauty of a Sony Nex 5. Okay, this is around 30 minutes. Okay, amperes used is around 15.7, just under 16 amperes. The voltage 18.12. And the power now, surprisingly, is around 280 watts. The voltage on each cell, I was just checking the camera is recording, the voltage on each cell is around 3.6 volts. I have to take a look at the camera and stay in the back. Sorry, the camera switched off again, and I think this is what it's going to be this time. So I guess if I do another movie, I'll just use a different camera. But believe me, it's still flying. I didn't land. You can see the watch. It's still in the same position. Now it shows that much. I think we started around 20 to 7. And now I put it a little bit like that. Okay, the camera is recording. Now, amperes used is just under 16 amperes. It sometimes it goes a little bit up, but just 1/10. The voltage is 18.04. And the power used 280, 282 watts. Okay, let's go up a little bit. I feel some little wind coming here, but just looking. Wait. Okay, now the clock shows 15 minutes, 16 minutes past 7. So this is something around 35 minutes or something like that. Still recording. The amperes used are the same, maybe a bit more, 16. If I go up now, so it would be around 16 amperes. The voltage 17.9. And the power used is more around 285 watts now. Still recording. And of course it is on a GPS mode. Okay, now the middle I mean hovering is just above the middle, so I would say that's around 60%. The GPS is LIA 6H, actually the one that came with the original pixhawk. Okay, take a look at the clock. This means 40 minutes. The voltage is 17.1. Amperes used 16.3 or something like that. It turned off again, and the power is 280, well, the same. Okay, as I said, one of the cell reached 3.1 watts, so we could fly a bit longer, but this could damage the battery, so I land. Okay, let's switch it off. Let's turn it off. Hold on. Okay, now the battery. Well, it's warm. Motors. Can you see that I'm holding it? They are just warm, just a little warm. Nothing. The battery is warmer than the motors. Okay, so what I did to the pixhawk is I put large rubber here, the camera turned off again. Okay, so what I did to the pixhawk, I just stripped it all here, put different rubber here where the barometer is inside, then covered the card hole and used very thick rubbers under the pixhawk, so it's sort of moving. And I think this is it. So this is what the copter looks like. Now, if the problem is solved with the barometer, I think I could, to use 17 inch propellers. As you can see, there's quite a lot of room, so I could, I guess I could move the motors and just shorten the booms. Okay, so this is it. Well, warm, but it's not bad. And this is just nothing, the motors. Okay, so this is it.